everyone, welcome back to my YouTube channel. So today we'll be solving the October-November 2024 physics multiple choice exam. So let's get started with it. So for the first question, a student uses a meter ruler to measure the length of a sheet of paper. Which measurement is shown to the nearest millimeter? You should be very much aware of your unit changes. You have millimeters, centimeters, and meters, and then the difference between them. So if you're moving from millimeter to centimeter, that's divide by 10, centimeter to meter, divide by 100. But moving in the opposite direction, you're going to multiply. And if you want to jump all the way from meter to millimeter, you're going to multiply it by 1,000. So basically just multiplying these two together. So what are we going to do? How do we confirm that B is the right answer? So if you have 0.293 meters, you multiply that by 1,000 to change it to millimeter. So basically move the decimeter over 3 times. So 1, 2, 3. And that would be 293 millimeters. And that's going to be the nearest millimeter. Why? Because it's a whole number. So if we were to do this one, it would have been 293.2, not a whole number. This one isn't the full thing either. Neither is that one. So B is your answer. So for the second question, a rocket travels with an average speed of 6 kilometers per second for 2 minutes. What is the distance traveled by the rocket? We're going to use our very trusty triangle. If you ever forget what the triangle is like, just think of the units. Those are really great to help. So you have your speed, which is kilometers over seconds. So you have distance, which is your kilometer. It's going to be on top. Seconds is your time. So at the bottom, that's how you can remember the triangle. So when you have the distance, you're going to do speed times time. And we want to just make sure the units are always correct and they're like the same. So 2 minutes, we're going to change minutes to seconds. So multiply that by 60. So within every 60 seconds, there's a minute. So minute and minute on top of each other, delete or just cancel out, just like 1 over 1 or 2 divided by 2, it still equals to 1. So we've basically got rid of it. And then we have seconds on the bottom here and seconds up here. So when you multiply all of this, it'll give you 720 kilometers. And the only unit left is kilometers, so you know you're doing it correctly. Now, for the third question, the diagram shows the vertical forces acting on a ball as it falls vertically through the air. The ball does not reach terminal velocity, so that is very important. Okay, so which row describes what happens to the resultant force on the ball and what happens to the acceleration of the ball as it falls through the air? So when we're talking about terminal velocity, air resistance is equal to the weight. So the resultant force is 0. And if the resultant force is 0, that means there's no acceleration. It's still falling, but it's not accelerating. So we're going to find the resultant force. So as the ball continues to fall, the speed is going to increase, but so is air resistance. So the force or the resultant force would be the weight minus the air resistance. And that's going to decrease. And that's only because air resistance is going to go up in value. So weight is going to stay the same regardless. But if air resistance keeps increasing, then that means the resultant force is going to decrease overall, right? Then acceleration, we know that acceleration is force over mass. And if force is decreasing, then acceleration is also decreasing. That is as long as, mass is staying consistent, right? That's not changing at all. So acceleration and force are directly proportional. Okay, so for question 4, a coconut falls from a palm tree at X. It has just started falling. Y is the point just before it hits the ground. Okay, so what is the acceleration of the coconut at X? So remember I told you acceleration decreases as you fall, right? Until you reach that terminal velocity, and then it's just 0. Because of air resistance. But in this question, they say air resistance can be ignored. So that means that the acceleration of the coconut at X is going to be exactly the same as Y. So for question 5, a car is driven around a bend in the road at a constant speed. Keywords, constant speed. Okay, so what is the direction of the resultant force on the car when it is going around the bend? So we're going to think of centripetal force if you're moving in the circular motion, like spinning a ball on a string, or like even a roller coaster, or even the planets orbiting the sun, right? So A wouldn't work because if we have a force parallel to the motion and the same direction as the motion, it's just going to increase the speed. The car's just going to go faster. If it's parallel to the motion and in the opposite direction, the car's just going to slow down. But perpendicular and inwards, that's centripetal force. That is correct. But if it's perpendicular and towards the outside, you have something called centrifugal force. It's something that we feel, but it's not necessarily real. It's just that velocity that we feel moving forward, and then the centripetal force pushing us in. So we feel like there's an outside motion, but an outside force, but it's not really there. Okay, so for question 6, the diagram shows a drawbridge that is attached to a wall by a hinge right here at one end and a cable at the other. The weight of the drawbridge and the tension in the cable are represented by the labeled arrows. There is a third force at the hinge, which is not shown. The drawbridge is in equilibrium. Again, keyword equilibrium. So which arrow shows a possible direction for the force at the hinge? So we just want the weight or the force to be equal at the bottom and at the top, so they cancel out and you're kind of just in equilibrium. You're not moving up or down. So in order to have that, we need something that is of equal and opposite force to the tension. So if the tension is facing that way, we need something in the opposite direction. And if you think about it, you also have like the force in their y direction and the force of this one in the y direction. And if you add them up together, so of the tension, for example, and of hinge, so the force of the weight should equal to the force of the y component of the force of the tension, and then the y component of the force of the hinge. And yeah, it'll be the same. It's as though this is equal and opposite. But yeah, so that would be D. And then for question 7, which equation gives the momentum change of an object? So change in momentum is mass times the change in velocity. And we know that force is equal to mass times acceleration. And another way to write acceleration is the change in velocity over time. So place that back into the equation, multiply the whole thing by time, and then you realize force times time is also equal to mass times the change in velocity. And that looks very familiar, right? So we can place the change in momentum here, and that just gives us the impulse. So momentum change is equal to force times time. So for question 8, which statement about the use of nuclear fuel as an energy resource is correct? It obtains its energy from the sun. That's not true. Solar energy comes from nuclear fusion in the sun. It has no environmental impact. That's not true. There's radioactive waste. You have to actually mine in order to get those radioactive metals like uranium. Nuclear power stations do not need turbines. That's not true. They're going to use the turbines to convert heat into rotational energy, and that drives a generator to produce electricity. So they do need them. The energy is released by nuclear fission, though. That is true. So by process of elimination, you know D is the answer. But if you do also know what nuclear fission is, then you'd be able to get this answer right away. So nuclear fission is the process of splitting a heavy atomic nucleus into 2 or more smaller nuclei. So fission versus fusion. Fusion is you're actually bringing 2 together, or how many more together, and then you're fusing it together. Okay, so for question 9, the diagram shows an object of mass m being projected with speed v from a point P to a point Q on top of a cliff height h. So the object does work against air resistance as it travels from P to Q. What is the kinetic energy of the object when it reaches point Q? So you want to find the final kinetic energy. Okay, so for this question, the initial and the final kinetic energy is not the same. That's because some energy is lost to air resistance, and then the fact that we've also gained some potential energy by moving up a cliff, hence why you're subtracting. But yeah, so then you end up with D, which shows the initial kinetic energy, which is positive. You're going to subtract the potential energy gained and the energy lost due to air resistance. And finally, for this video, question 10, or at least part 1, the diagram shows a Sankey diagram for an electric drill. I placed an image in case you didn't know what an electric drill is. What is the total wasted energy shown by the diagram? So first step is identify which energy is the wasted one. that would be sound and the thermal energy, because we do need the kinetic energy with this drill. It could be different if they didn't ask for an electric drill and they asked for something else, so you just have to be careful. Now, in order to calculate the wasted energy, we look at the width, and then also the fact that they told us the distance between two lines is 40 joules. So we have 1 here, so 1 square, then we have 4, so 5 times 40 joules is 200 joules, so your answer is B. And that's it for part 1. Let me know if you guys have any questions in the comment section below, and I'll be creating parts 2 to 4 later on. So subscribe if you found this helpful, and I'll see you guys next time. Bye bye.